How does electricity flow in wires? Have you ever wondered what happens inside a wire when you flip a switch and the lights come on? Let's break down the fascinating journey of electricity flowing through wires. Electricity flows in wires mainly due to the movement of tiny charged particles called electrons. These particles are found in atoms, and in materials like copper, some electrons can move freely. When a voltage, which is the difference in electric potential, is applied across a wire, it creates an electric field inside. This electric field acts like a push, driving the free electrons to move and create an electric current. Think of the wire as a pathway. The voltage pushes electrons from the negative side, where there are more electrons, to the positive side, where there are fewer. For this flow to happen, there needs to be a complete circuit. This means a closed loop that allows electrons to travel from the power source through the wire to a device like a light bulb and back to the source. Interestingly, the actual movement of electrons is quite slow. They drift at a speed called drift velocity, which is much slower than the speed at which the electrical signal travels. The energy transfer occurs through an electromagnetic field surrounding the wire, which moves close to the speed of light. This field carries the electrical energy from the power source to the device, while the electrons themselves move more gradually within the conductor. The material of the wire plays a significant role in how easily electrons can move. Copper is a great conductor because it has many free electrons and low resistance. Resistance is what happens when electrons collide with atoms inside the wire. These collisions slow the electrons down and cause energy loss in the form of heat. Factors like the thickness, length, and temperature of the wire can influence resistance and, in turn, how efficiently electricity flows. In practical terms, power plants generate electricity by spinning magnets inside coils of wire. This motion creates electric fields. The electricity produced is then transmitted over long distances at high voltages to minimize energy loss. Transformers adjust the voltage up or down to deliver electricity safely to homes and businesses. Inside buildings, wiring systems and circuit breakers ensure that electricity flows safely and only when needed, such as when you turn on a switch. So, to sum it up, electricity in wires is all about the flow of electrons driven by an electric field created by voltage. The energy travels via electromagnetic fields around the wire, while the electrons drift slowly through the conductor. This process powers our everyday devices, lighting, and technology, connecting the principles of electricity to our daily lives.